वो सब्जी धोना सिखाते होंगे।
अरे
एनीवे कुछ तो होगा ही होगा भाई। ओके। चलो कपड़ा लो, साफ करो, काटेगा होटल मैनेजमेंट वाला। ओके, सो लेट्स टॉक अबाउट relationship between relation between torque, rotational force, and movement of inertia. Okay, so we know the linear acceleration of the particles is equal to this. So alpha is the angular acceleration, a1 is the linear acceleration, and the force acting on the particle is m1 into a1 is equal to m1 r1 into alpha. Multiply both the sides. So if you have a rigid body, so this is your rigid body made up of hundreds of small masses. So all the torques, first torque is F1 R1. Assume this is the center of mass. So this is R1. This is center of mass. This is R2. So torque on this body, first point mass. So this is your rigid body. Rigid body. So all the torques put together on each of the particle masses will be given by sigma tau 1 is equal to I is equal to 1 to n. Ti is t tau 2 to tau n, and we know
sir,
f1 can be written as this. हाँ जी,
sir, it's not tau, it's tau.
ताऊ जी ठीक है। ताऊ जी के घर गए थे तुम? ताऊ जी के। सो अल्फा ये आ गया, और m1 r1 स्क्वायर से लेके mn rn स्क्वायर I alpha. So the total torque acting on a body is a product of its angular acceleration and moment of inertia. So when you apply torque on a body, which has some moment of inertia, that means you try to turn the body, then the torque is a product of moment of inertia and angular acceleration.
ठीक.
So this was more of just a small derivation for you, nothing else. कुछ नहीं था।
तो तुम डेरिवेशन ही कर रहे हैं वैसे भी कब से.
हाँ जी। क्यों, हमने पिछली बार बहुत सारे न्यूमेरिकल करे हैं भाई।
हाँ पिछली बार 2 बार कर रहे थे.
यस। ओके, सो टेल मी, इफ अ बॉडी इज undergoing change in angular velocity, will it have an angular acceleration?
कैसा.
If a body
हाँ जी.
a body is undergoing change in angular velocity, will it have an angular acceleration or
यस.
not?
यस यस.
Good. Okay. What is the expression of angular acceleration? Please write it.
आर ओमेगा स्क्वायर.
Centripetal. You're telling me radial. I am asking you angular.
ए एंगुलर एक्सेलरेशन.
Ji. You are telling me
मैं.
radial. Centripetal. I am asking you angular, which is because of change of d theta by dt, d omega by dt.
ओमेगा
Please
डेल्टा
draw a
ओमेगा बाय
vector
डेल्टा
also.
टी.
Please draw a vector also that shows the angular acceleration and the centripetal acceleration. एक
ठीक.
वेक्टर डायग्राम बनाओ जो एंगुलर एक्सेलरेशन भी दिखाएगी और टेंजेंशियल एक्सेलरेशन भी दिखाएगी किसी पर्टिकुलर बॉडी की। What is the difference between angular acceleration and tangential acceleration? Let me see what
tangential.
have you done. So three terms for you. Okay, one is radial acceleration, which you know is same as centripetal acceleration. ठीक है?
हाँ जी,
Both are same. So radial and centripetal acceleration are same. Fairly well understood. Second point, what is angular acceleration? Alpha is equal
अल्फा
to derivative of omega.
डीवी बाई dt,
Omega.
डी ओमेगा बाई dt.
Third term, linear tangential acceleration. Okay, linear tangential acceleration. तीसरी जो होती है, जो मैंने लिखी है यहाँ पे, इफ यू सी द डेरिवेशन, ए भी लिखा था ना मैंने एक. सो ये लीनियर एक्सेलरेशन क्या होती है? ए आर अल्फा. So if a body has a angular acceleration alpha, the corresponding linear acceleration it has is r alpha. तो तीन वर्ड्स मैंने लिख दिए हैं. My question to you is draw a vector diagram. So you showing me this vector diagram. This is the radial acceleration. ठीक है? AR. ठीक है? And then you have alpha. And how is alpha linked to the linear tangential acceleration like this? So this particular vector therefore represents A tangential. Because ये यूनिफॉर्म सर्कल नहीं है.
हाँ जी,
ये टेंजेंशियली वेलोसिटी सेम नहीं होती है. अगर ओमेगा बदल रहा है तो v भी हर पॉइंट पे बदल रहा है. अगर v बदल रहा है तो चेंज, तो इसका मतलब लीनियर एक्सेलरेशन भी है इसके पास. द रिजल्टेंट ऑफ दीज टू, विच इज द radial acceleration and tangential acceleration. Let me draw the parallelogram. तो मान लो ये parallelogram बना लिया मैंने, right?
okay.
So इन दोनों का एक्सल resultant will be this, right? This is the net linear acceleration of this body. क्योंकि straight line में है, तो it is basically square of the centripetal acceleration and square of the tangential acceleration. A resultant. So when I've used alpha here in the second line, remember I wrote F is equal to M into A. When I said A, a body rigid body है, and I'm saying A1, तो rotational motion है, और ये बात हो रही है A1 की, तो लीनियर एक्सेलरेशन अगर है उसके पास, वो कहाँ से आ रही है? R alpha से, because it has a angular acceleration also.
ठीक.
वेक्टर डायग्राम थोड़ा समझ में आया?
हाँ जी,
Okay. So look at the, so A पहले ही लिख दिया था मैंने, लीनियर एक्सेलरेशन का फॉर्मूला. ये बॉडी के पास हमेशा ही है, क्योंकि ये जब ये रोटेट कर रही है अबाउट दिस एक्सिस, मान लो जैसे सिलेंडर था वो था, तो घूम रहे हैं ऐसे, राइट? कोई उसके ऊपर एक पर्टिकुलर मास ले लो, राइट? सो यू विल से ओके, द तेज तेज चक्कर लगाना शुरू हो गया वो, तो उसका ओमेगा बदल रहा है. दैट मीन्स इट ऑल्सो हैज अल्फा, because it has d omega by dt. If this sphere, for example, which is rotating, has alpha, and therefore it also has a r alpha, which is its linear acceleration of the same point. So this point is also having a linear acceleration here. And radially, it is being moving towards its center of mass. So this is the central, this is the radial. Sorry, this is the central or radial, this is the tangential.
ठीक.
The square of the resultant of these two is the net resultant acceleration on the body. आया समझ में?
हाँ जी,
Okay. Solid. Let's move forward. Okay. So next topic. Okay. Um, again, you have to study about the yeah, one more relationship. So torque, moment of inertia, and now torque and angular momentum. Sorry, angular momentum and the moment of inertia. जैसे कि second part of the series is the relationship between angular momentum L, and the second thing you need to know is its relationship with moment of inertia. This is like saying I will find a relationship between momentum. Yeah, why do you keep your camera switched off here?
ऐसी
क्यों? Because मतलब you're ashamed of your face or what?
um,
You should keep it on. P and M. क्या रिलेशनशिप होता है? लीनियर मोमेंटम इज इक्वल टू M इंटू V, राइट?
हाँ जी
उसी तरह से P का भाई L है रोटेशन में. मास का कौन है? I.
हाँ जी
P का कौन है? ओमेगा.
ठीक
So L is equal to I omega. That's a rule. Relationship between the L is equal to I omega.
ओके
Angular momentum is a product of moment of inertia and the angular velocity of a body. So if a body has dl by dt, which means it is showing a rate of change of angular momentum, a torque is getting applied on it.
ठीक
Okay.
ओके
Is it true that if the angular velocity of a rotating object changes, if the angular velocity of a rotating object changes, it has to have tangential acceleration?
यस
Correct. But is it true that if an angular velocity is constant, then each point on the object will still have a centripetal acceleration?
नो नहीं
Why?
एक
Why each point on the object won't have a centripetal acceleration if omega is constant?
कांस्टेंट है
Omega
तो
square
एक्चुअली
r? Centripetal acceleration is v square by r.
हाँ जी
V is equal to r omega. R square omega square divided
एक्सिस
by r equal to omega square r. So even though you are at constant angular velocity, you still
कांस्टेंट
have a
एंगुलर सेंट्रिपेटल एक्सेलरेशन
होगी ना? That's what I asked you. True or false?
अच्छा ठीक
Just be very careful on this chapter. This is a different type of chapter. Not that it is difficult, but it does require concentration of separate level. Okay. What is the moment of inertia of a thin hoop?
ऊप ऊपर
Yes.
मतलब
Ring
रिंग अच्छा
about an axis passing through its center of mass. याद करी वो 21 figures?
नहीं वो याद नहीं करी है
नहीं करी तो भैया फिर enjoy yourself.
याद याद
Just be very careful on this chapter. I'm again telling you कि ये chapter जो है
ले लेगा
बहुत ही मतलब this is going to put you in trouble. Please explain the parallel axis theorem. So I'm just telling you what are the questions you can expect in this chapter. What is parallel axis theorem?
ठीक
बताओ जी क्या होती है अगर बताना पड़ जाए.
according to the parallel axis theorem
Yes.
a body's moment of inertia about any axis is equal to the product of that body's mass and the square root of the distance between the axes.
Square root. You
This
told me gyration या व्हाट डिड यू टेल मी भाई? क्या बता दिया?
पैरेलल
सेंटर ऑफ
एक्सिस।
मास का तो नाम ही नहीं लिया पैरेलल एक्सिस थ्योरम में. द फर्स्ट थिंग यू हैव टू मेंशन इन एनी पैरेलल एक्सिस थ्योरम इज द सेंटर ऑफ मास. जो मोमेंट ऑफ इनर्शिया सेंटर ऑफ मास पे होता है प्लस एडिशनल मोमेंट ऑफ इनर्शिया जो उससे आगे जाके एक्सिस बनता है, उतना एक्स्ट्रा और भी ऐड करना पड़ता है. लुक एट दिस. तो ये इसका ये वाला एक्सिस है. इस एक्सिस के अराउंड इसका मोमेंट ऑफ इनर्शिया आई सी एम.
ठीक
लेकिन आपको बोला एक एक्सिस है उसके पैरेलल, ये वाला जो डिस्टेंस h है जिसका फ्रॉम द सेंटर ऑफ मास एक्सिस. तो दैट एडिशनल मोमेंट ऑफ इनर्शिया बिकॉज ऑफ you shifting the axis by an amount h from the center of mass, that additional moment of axis also needs to be, sorry, moment of inertia needs to be added. Generally, what we study in the standard figures is the moment of inertia passing through the center of mass. फिर वो along the tangent, along the diameter, this that करके we are able to calculate other moment of inertia of the same body along different axes.
ठीक. ठीक.
What is the definition of power in this chapter? Power को कैसे define करोगे? If you have to solve a question of power, what is the expression? Power is dW by dt, rate of change of
जो
work.
क्लासिकल मैकेनिक्स में.
उसी की analogy अगर लिखनी पड़ जाए, that power from previous chapter, from a general definition we know, is dW by dt.
Yes.
इस चैप्टर में प्लीज कन्वर्ट दिस पावर in terms of the new quantities you know for a rotational motion. How will you write? ये जनरल एक्सप्रेशन है.
रोमन लिख.
Okay, so yes, so you have actually copied that force into velocity. फोर्स का इक्विवेलेंट टॉर्क है, v का इक्विवेलेंट ओमेगा है. सो टॉर्क d थीटा बाय dt ओमेगा.
Yes.
ठीक है.
tau into omega.
Okay, fair enough. All right, so first numerical on this.
सर
हाँ जी,
कहाँ पर न्यूमेरिकल
क्या कह रहे हो?
न्यूमेरिकल दे रहे थे ना.
Yes, just copying and pasting. लो जी करो फर्स्ट वन. So that is 10 raised to power minus 4. Power ऊपर नहीं आ रही है. So there is a torque and it produces alpha to find moment of inertia of the body. Straightforward.
ठीक है.
करो जी. Your
हाँ
turn to
जी.
do. I'm
हाँ जी, हाँ
waiting
जी,
for
मैं
you to
कर.
do.
नहीं नहीं नहीं.
You can use the formulas which you have learnt above.
हाँ जी.
Torque is equal to I alpha.
हम्म, हो गया.
Straightforward था. There was nothing to do. Just apply the next question. Please ensure that you write units kilogram meter square. एक नंबर का क्वेश्चन होगा, आधा मिलेगा.
जस्ट अ मिनट.
Yes. Worries. This is easy one. I think linear speed is given. So you have to find average negative torque transfer to. So the wheel, okay, 15 सेकंड में व्हील को रोक दिया. ओके, आई दिया हुआ है और obviously it has a linear velocity and 15 सेकंड में it comes to rest. So you know if a body is in linear motion, it can have a negative acceleration during braking.
सर A equals to R alpha.
सही है. First find A.
A निकल जाएगा,
Final velocity is 0. It stops.
यानी कि minus U is equals to 80.
Yes. So this is your
minus minus 10 is equals to
ठीक है, तो
a
ब्रेकिंग
by
आ जाएगी ना, ब्रेकिंग. सो A इज इक्वल टू -2/3 मीटर पर सेकेंड स्क्वायर. ब्रेक लग रही है. ओके, सो दिस
अब
इज राइट.
दिस इज द क्या कहते हैं अल्फा आ जाएगा.
निकालो.
अल्फा
करेक्ट है. थॉट इज करेक्ट.
-2/3
हम्म.
into 100/35.
हम्म.
Okay. क्या आएगा ये, क्या बनेगा?
So you got your A, and now you're calculating your alpha. A by R.
200. सॉरी,
Okay.
35 into 3 कितना होता है? 105.
105.
1.9 यानी कि 2 ही आ गया अप्रोक्सीमेटली.
15 seconds it took to stop. Okay. Yeah. So कितना
माइनस
आएगा
टू
ये?
-2 आ गया.
क्या?
अल्फा अल्फा.
Okay. Let's see. A is equal to R alpha. Hmm. देखो ये जब लगाते हैं ना, दिस इज अप्लाइड ओनली व्हेन यू हैव प्योर रोलिंग. रिमेंबर, ये
तो
प्योर रोलिंग में अलाउड होता है सिर्फ.
प्योर रोलिंग है तो ये स्पेसिफाई नहीं करा.
हाँ, मतलब एनी पॉइंट ऑन द सेंटर ऑफ मास V इज इक्वल टू R ओमेगा फॉलोज दिस. ये रेस्ट पे होता है पॉइंट, ये वाला पॉइंट 2V होता है. सो जस्ट बी वेरी केयरफुल. सो 2/3 इज फाइन. देन यू हैव सेड ओके आई विल डू अल्फा इज कमिंग आउट टू बी कितना आ गया? अल्फा 2 आ गया. अच्छा. ओके.
अप्रोक्सीमेटली 2 वैसे -6
-6.
टॉर्क. नेगेटिव टॉर्क है ना, तो -6.
हाँ. Let me check your. This is U. What? How did you get uh, A to be 10?
A to be 10.
हम्म. ये
सर
A
उसको मीटर पर सेकंड में कन्वर्ट करा ना.
किसको? स्पीड को?
हाँ, नहीं एक मिनट, 10 कैसे आ गया?
36 होता है, समझ नहीं आया.
नहीं, एक मिनट एक मिनट.
V is equal to U plus 80.
हाँ. नहीं 15 होना चाहिए.
-1 आ रहा है. तो अगर दिया नहीं तो assume it to be pure rolling, कि वो रुकता है. There is no slipping, क्योंकि लिखा नहीं हुआ कहीं पे
मैं
कि it
थोड़ा
slips.
कैलकुलेशन मैंने गलती से.
And also note that कहीं लिखा नहीं it slows down with slipping. So it is the case of pure rolling. हम्म.
alpha is -1
हम्म.
and tau is equals to 3 into -1, which is
जी.
-1.
जी. अब सही हुआ है. Or you have not written units again, so Newton meter. Just give me 1 second. I'm giving you 3, 4 questions. Just give me 1 second, please. Just give me 1 second. So I'm giving you 1 second. Just give me 1 second. मैं 5 मिनट में आ रहा हूँ, ठीक है? Am I audible?
हाँ हाँ.
Okay. Just give me.
पापा कहीं जा रहे हैं?
All right, I'm back.
हाँ जी.
हो गया?
नहीं बस.
Hey, why I'm not visible on this, यार? आ रहा हूँ मैं कैमरे में.
हाँ जी.
मैं अपने आप को देख नहीं पा रहा. Where am I? अच्छा, okay.
व्हाइट
I
बोर्ड की
can
वजह
see
से नहीं
you.
देख
Yeah,
पा रहे
yeah,
हो.
okay, okay, got it. Standard कर दिया मैंने. Somehow मैं खुद को नहीं देख पा रहा, but ठीक है. It's fine.
What
A
force should be
flywheel of mass. Okay, it's a flywheel. Great.
tangential force? Okay. ठीक. Sir, 10 Newton. 10 Newton.
Okay. How have you done this? So A is equal to R alpha, A is equal to 0.2 into 2 meter per second square. Okay. And what was this? What force should be, so that requires an angular. Okay, so this was alpha, R alpha. A निकाल लिया, ठीक है, बढ़िया, सिंपल.
Math.
मतलब एक सेकेंड, व्हाट इज अ टॉक अप्लाइड?
टॉर्क क्यों निकालनी है? टॉर्क तो पूछी नहीं.
ओके, आई अल्फा.
निकाल लो टॉर्क.
नहीं, रूल क्या लगाया है, समझ नहीं आया. कौन अंडरस्टैंड? ये कौन सा रूल लगाया है, लीनियर एक्सेलरेशन? एंगुलर एक्सेलरेशन इतनी है, लीनियर एक्सेलरेशन इतनी है. अच्छा, एक फ्लाईव्हील है, उसका रेडियस इतना है. यू आर अप्लाइंग टॉर्क, ओके, सम फोर्स. This is the radius. The angular acceleration is 0.4. Mass into acceleration. ये क्या है?
फोर्स.
टेंजेंशियली लगाई है या सेंटर ऑफ मास पे लगाई है?
टेंजेंशियल.
ये रूल तो F इज इक्वल टू एम ए जो होता है, तो सेंटर ऑफ मास पे लगाते हैं वो. ये क्या लगा दिया? इफ यू नो, इट्स अ फ्लाई व्हील, इट्स अ डिस्क, राइट? एंड आई अल्फा is equal to torque is equal to F into R. Torque is F into R. I, because it's a disk, alpha is given, is equal to F into R. So F इससे आएगा. Find alpha first using disk knowledge of disk.
अल्फा तो दे रखा है 2 रेडियन पर सेकंड.
I mean moment of inertia mr square by 2 होता है.
ठीक है.
I think what the force you have found out is as if the force is being acted on the center of mass. ये force जो आती है.
अच्छा. वन बाय 0.2. 5 न्यूटन.
The acceleration was tangential, remember.
ठीक है.
It was not वो वाली F is equal to ma, जो सेंटर ऑफ मास पे A, ये टेंजेंशियल है ऑन अ रिजिड बॉडी. A at the tangent. Next. हाँ जी. So it's a flywheel, which means the moment of inertia is mr square by 2. So mk square, right? So you can apply the mass, and so mk square will tell you the moment of inertia, because instead of giving you the distance, he has given you the radius of gyration itself. So moment of inertia is mk square.
Okay. 2.5 kg meters.
Yes.
हाँ जी आगे. So 4 ads per second square.
सही है. Next.
What is a grindstone?
ग्राइंडिंग है जो काम आता है, चक्की पीसिंग.
चक्की पीसिंग. वाह.
डिस्क.
जिससे
आटा, हाथ से.
आटे के लिए
चक्की पीसिंग.
चक्की पीसिंग. वाह. नहीं, नहीं नहीं चक्की नहीं होती, कुछ और होता है ग्राइंडस्टोन.
ओके. ग्राइंडिंग लिखा है, तो मुझे तो वही लग रहा था.
नहीं, कोई तो है ऐसी, कोई फ्लाइंग व्हील जैसा सा होता है.
ओके. आई दिया हुआ है, टॉर्क दिया हुआ है, और टॉपिक इज टॉर्क इज इक्वल टू आई अल्फा. Alpha is angular acceleration. So you start from rest and your revolutions per minute go up. 0 revolution per minute से
आगे से
Okay, so omega final. Okay, omega initial, omega final is equal to omega. Okay, alpha torque is equal to. सही है, बढ़िया. Okay, so torque. Next question.
कॉर्ड कॉर्ड का तो कॉर्ड होती क्या है
रस्सी.
रस्सी
रस्सी.
ओ
NCRT question.
तो उसमें से हिंट देना
Hint. Okay. So you have a rim of flywheel, right? So this is your flywheel. This is your flywheel and it is pulled up. तो इसका मतलब एक साइड पे मास है, इस साइड मास है, It is pulled up, तो ये पुली का काम कर रही है.
Yeah.
So you are supplying 25 newtons. Achha, sorry. It says as shown in the figure. So let me give you the figure then ना. Why do I create the figure? Okay. कैसे खींच रहे हैं वो exactly दिखना चाहिए. तो ऐसे खींच रहे हैं. मेरी वाली फिगर जो है वो मैं देख के बना रहा था, बट करेक्ट फिगर इज दिस. दैट्स योर फिगर. ऐसे खींच रहे हैं इसको नीचे से, ऐसे फिर गोल घूमता है. अगेन इट्स अ फ्लाई व्हील एंड द एक्सिस ऑफ रोटेशन इज हेयर ओनली. ये इस एक्सिस के अराउंड ही घूम रहा है. mr² by 2. एंगुलर एक्सेलरेशन निकालनी है. फोर्स इज दिस. टॉर्क विल बी F into R equal to I alpha. सो फोर्स इंटू फोर्स आर्म भी लग रहा है. टॉर्क का दूसरा फॉर्मूला.
I alpha
जी.
is equals to F into R.
हम्म.
mr² by 2 है ना.
हम्म.
तो 20 into
Yes, torque is equal to F into R.
twelve point five rad
जी.
per second square. So find the work done by the pull.
Hmm. You told
And
me the
pull
value of. So how much is the force you've applied?
हमें तो angular acceleration करना.
Hmm. But what is the force
force
you have applied?
100,
25 newtons, right?
25 Newton, yes.
Right. तो जो भी ये है, मान लो this was a weight. So this weight lost how much potential energy? By weight is 25, right?
And,
And 2 meters it has come down.
yeah,
Force into distance, force into displacement
ठीक है.
is the work done. They're in the same direction.
No, 100. This is
Yes.
50,
2 meters, 50 joules.
50 joules.
Yes. So if it loses, okay, you can write it.
The
F
kinetic
into,
energy.
हाँ जी. So whatever loss is there in the potential energy, ये loss of potential energy है because it has come down.
Hmm.
You can't lose the work because you're on a conservative field.
ठीक
You
है.
can't lose the, अगर potential energy गुम तो नहीं हो जाएगी ना, it will get
100.
converted to some other form. So 50 joule is equal to half mv square.
ठीक है.
Conservative field है ना, there is no loss like dissipation. ये गुम हो गई.
ठीक. Also find the kinetic energy, half mv square.
Yes.
So 25 Newton is equals to
Rotation है, remember.
uh,
The kinetic energy is gained by the wheel. Wheel is not coming down. But definitely whatever loss is there, potential energy का, वो मिला किसको? Wheel को. So wheel became half I omega square gain हो गया. And you know, right? इसकी speed बढ़ी है.
हाँ जी, वो तो रोटेशनल kinetic
हाँ,
energy है.
तो whatever is mgh is equal, a loss in mgh is getting converted. The work done in pulling this, you did work, right?
Hmm.
Where did that work go? To rotate the pulley or the wheel. तो pulley अब घूमने लग गया है. So 50 joule is equal to half I omega square.
ठीक.
करो जी पूरा. काइनेटिक एनर्जी तो ओमेगा निकालना है 2 मीटर के बाद. दैट ऑल्सो नीड्स टू बी फाउंड आउट, क्योंकि हाफ आई ओमेगा स्क्वायर में यू डोंट नो ओमेगा, राइट? ऑल्दो यू कैन अप्लाई दिस ऑल्सो, द रैशनल आई टोल्ड यू. 50 joules also converts to half I omega square. This is one.
Okay.
You did work, right? वो वर्क जाएगा तो कहीं ना. It has to go somewhere. Calculate. Kinetic energy gain should be how much? But if they say prove it, how will you prove it? एक तो लिख सकते हो लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, वर्क एनर्जी ट्रांसफॉर्मेशन.
हाँ जी.
Work energy transformation. You did work, it got transformed into some energy. How much work you did? Force into force sum.
ठीक.
It. So this is one rationale you can give.
Oh.
You can straight away write using the work energy transformation theorem. वर्क एनर्जी ट्रांसफॉर्मेशन थ्योरम क्या होती है?
वर्क एनर्जी ट्रांसफॉर्मेशन थ्योरम
क्या होती है? व्हाट
E
इज इट?
अपॉन क्या कहते हैं, E स्क्वायर अपॉन 2m.
I'm asking you the what is uh, what is the meaning of the word energy transformation?
अच्छा.
जब हम बोलते हैं कि कोई भी जो सिस्टम होता है उसके पास एक एनर्जी होती है.
ओके.
ठीक है. वो
ठीक है.
क्या क्या स्टेट्स में होता है सिस्टम? इट कैन हैव, लेट मी गो टू द नेक्स्ट पेज सो दैट यू कैन. मैं बीच बीच में आई एम जस्ट पिकिंग प्रीवियस टॉपिक्स ऑल्सो. Okay, so you have a system. Now, system has three energies, for example. One is potential energy.
ठीक है.
By virtue of its position with respect to Earth's surface. MGH wali, gravitational potential energy. It can have kinetic energy.
ठीक है.
It can also have energy due to temperature, thermal energy. पढ़ेंगे आगे हम थर्मोडायनेमिक्स में, हीट में. It can also have a spring potential energy. मान
हाँ
लो
जी.
this is the body, it is connected to a spring. So it is going up and down. तो gravitation भी involved है, spring compression भी involved है, और spring का extension भी involved है. Spring खिंच के यहाँ पे आ गया. So there is mgh also, and there is a half kx square also. So it can have a spring potential energy also. So any system, okay, if you say I have a system, that's your system. Now,
हाँ जी.
every system is characterized by some energy. And all the energies which I have written, gravitational potential energy, kinetic energy, heat energy, spring potential energy, spring के compression और extension पे dependent. Any system contains these energies. ठीक है? Now the energies, if they are in an conservative field, can transform between themselves. आपस में चेंज होती रहती है एक सिस्टम की.
ठीक है.
ठीक है, जैसे मैंने इस बॉडी को 10 मीटर पर सेकंड से खींचा, वो यहाँ पे आके रुक गई, स्टॉप्स. व्हाट हैपेंस? द पोटेंशियल एनर्जी is stored in the spring by way of extension, and there is a loss of height also. So whatever work I did to pull it down got stored inside the spring and appeared in the form of a loss of a potential energy. So जो spring mass system है, spring mass system को अगर मैं किसी एनर्जी से शुरू करता हूं, मान लो मैं उसको वर्क डन करता हूं उसके ऊपर, सो आई डू अ वर्क ऑन इट. That work then goes into changing some of these. But if it's a conservative field, obviously it will change, but interconversion will happen. GPE may become KE. जैसे कि अभी हमने देखा, ये कॉर्ड से हमने इसे खींचा, you did some work, right?
हाँ जी.
अगर मैं पुली की बात करूं, so पुली gained half I omega square. बट व्हाट अगर यहाँ मास होता तो उसके बारे में हम क्या बोलते? इट लॉस्ट 50 जूल्स, राइट? इट लॉस्ट हाइट, नहीं 2 मीटर नीचे चला गया वो. तो विद इन every system is characterized by an energy, and those energies keep on moving. Energy then moves between different forms. Gravitational potential energy is a form, kinetic energy is a form, heat energy is a, तो आपस में ट्रेवल करता रहता है depending on the type of work you have done, but it is not lost. You don't lose energy from the system. But if you have energy which is uh, lost because of friction, then the system is bound to lose energy, right? So what are you doing in case of conservative fields? When you supply work, work is supplied, right? So a system, you say this system has 10 joule. I want to increase the energy of the system to 15 joules. You will do work on the system of 5 joules. So 10 joule which the system has, due to work, it gains another 5 joules. Now the system has a total energy of 15 joule. Whatever work you did, for example, you extended the spring and you didn't do anything. तो जो 5 जूल था वो इधर आ गया. अब नई सिस्टम जो सेम सिस्टम है, So work is nothing but हम बोलते हैं positive work. A positive work gets added into a system as a energy. But if you do negative work, the system loses energy. And generally,
Okay.
negative work is done when the force you use to do the work is non-conservative. So if you have a system which is this is your system, okay? That's your system. That's your system. And it is made up of multiple energies, rotation, kinetic, potential, spring. So ये basically एक, this is a wheel which is connected to a spring. And so ये नीचे भी जा सकता है, रोटेट भी कर सकता है. अगर नीचे जा रहा है तो इसकी लीनियर वेलोसिटी भी है, रोटेट करता है तो इसके पास रोटेशनल काइनेटिक एनर्जी भी है. तो स्प्रिंग and mass system. Okay, so this has a mass, for example. Generally, pulleys are supposed to be massless. But let's say यहाँ पे एक और mass लगा हुआ है, चलो. Okay, so pulley is still massless, but then you're pulling it from here. And so whatever work you're doing by way of pulling it down is getting stored here as half kx square, because you are in a situation of positive work which you are doing, and that will appear somewhere in the system of spring and the mass. You may do 10 joules, right? And 10 joules may result in a storage of energy here, and this may come down, and it may be gaining velocity also because it is going down because of the power of mgh. अपना भी ये sorry ऊपर जा रहा है मान लो, because you're pulling it down, it is going up. So it also is gaining half mv square because ये धागे से जुड़ा हुआ है टेंशन. हाफ mv square भी गेन कर रहा है और अर्थ से भी ऊपर जा रहा है थोड़ी देर के बाद, तो it also gains mgh. And this spring also is gaining half kx square. So whatever work I'm doing is being given to this system in 3 energies.
Okay.
So if you have 10 joules, for example, the system was in a particular state. ये इसके पास शुरू से 8 जूल थे because of इसकी already extension कर रखी थी इसी पुली ने, या weight जब था और सब equilibrium में था. इसके पास potential energy थी 10 joules, and it also had a kinetic energy of 2 joules. Okay, it was moving also. So initially the system had 8 plus 10 plus 2. This was a total energy of the system at the commencement of work done. Now you started doing work on top of this, and your work now gets into the system, and now you're new and you do 10 joules of work. And then you look into the system and say, am I doing positive work or negative work? So you're not doing any work which is resulting in dissipation. You're only doing transformation work, which is the work is getting converted into the inner total energy of the system. Now, when you notice the total energy of the system in conservative force situation, so 10 plus 10 plus 10, this has come from the work done. And it may appear in any 3. It may come as an increased potential energy of the spring. It may come as an increased potential energy due to height, and it may also come because of the kinetic energy gain of this mass. So when I say work energy transformation, I am saying by doing work on a system which already has some energy, I am adding more energy to it. Generally, I am saying there is no friction. Generally, friction is mentioned, there will be a loss. Which मैंने कहीं friction बोला नहीं क्वेश्चन के अंदर.
Okay.
Okay, tell me. So कई लोग इसको see the language may vary. A lot of people will disagree with me and say what you just explained was work being transferred to a system, and therefore the elevating the energy of the system. Yes. So some people say you just did this transfer of energy to the system using work done.
Okay.
So a lot of people don't prefer to use the word transformation. They say the word transformation should be used only when you have negative work, which means if your car is moving on a rough patch of road, okay, this is a road, यहाँ smooth है, कोई loss नहीं हुआ, फिर ये rough patch आ गया. इस particular area में you entered, and you maintained your energy, say 10 joules, and then when you started moving through this, you lost 4 joules, and when you came out of this, you were 6 joule. They say the transformation word should be used only when there is a loss of energy. Okay, loss of energy is there. So when you notice the tires of this car heat up, okay, they're very hot. So energy got
Okay.
transformed from the kinetic energy to thermal energy, and it was dissipative in nature. So generally, some people don't call it, don't prefer to call it uh, work energy transformation, because they say that if you use transformation, you are referring to friction type of situations. पहिए में कई बार धुआं भी आ जाता है, अगर रेसिंग कार कभी देखी है स्किड
हाँ
होते
जी.
हुए, right? वो क्या है वो, that is, they say that is transformation of energy. What I explained you by way of adding energy to a system by doing work on the system, they say it is called as transferring energy, which means the work is capable of changing the energy system. E2 minus E1 is equal to work done. That is the way they look at it.
ठीक.
Work is equal to delta E. So you had some questions in your paper also pertaining to this work energy transformations में.
ठीक.
So generally remember the systems which I refer to, where the work is capable of doing this, E2 minus E1. This type of situation where there is a system with energy E1, I come and do some work on it, it gets added to it, and now the new energy of the system is E1 plus W. So these systems are called as isolated systems because there is no leakage in them. They're completely isolated, and the energy transformation, which is the loss, doesn't happen. Only transfer happens. So there is no leakage. They're completely covered and all that.
ठीक है.
What is work with this logic? So work, what does work become? Work becomes a push or a pull mechanism. अभी हमने जो व्हील था उसे खींचा था ना ऐसे.
हाँ
It
जी.
was a pull mechanism, right?
Yes.
What is it doing? Finally, the work. It is transferring energy, right, to the system.
हाँ जी.
भाई मेरा सिस्टम था ये रोटेशन के लिए, मेरे पास एक व्हील था ये वाला, और मैंने यहाँ वर्क कर दिया. सो वर्क बिकेम अ मैकेनिज्म टू ट्रांसफर एनर्जी टू दिस. सो वर्क इज अ पुश एंड पुल मैकेनिज्म which can most of the situations you see of conservative field ends up giving energy, transfers energy to a system. Okay, transfers energy to a system. बट अगर ऐसा मैकेनिज्म हो जाए जो लॉस कर दे एनर्जी का, काइनेटिक एनर्जी आपकी कम कर दे, फ्रिक्शन है जैसे, राइट? फ्रिक्शन ऑल्सो डज वर्क, बट वो नेगेटिव वर्क हो जाता है. देन इट इज ऑल्सो ट्रांसफरिंग एनर्जी, बट फ्रॉम द सिस्टम टू आउटसाइड द सिस्टम. सिस्टम से बाहर आ गई ना एनर्जी. जबकि हमारे आइसोलेटेड सिस्टम के अंदर देर आर मल्टीपल टाइप्स ऑफ एनर्जीज अवेलेबल. पोटेंशियल एनर्जी, दिस एनर्जी, काइनेटिक एनर्जी. वो एनर्जी आपस में घूमती रहती है. काइनेटिक पोटेंशियल में बदल जाती है, पोटेंशियल स्प्रिंग में बदल सकती है. लेकिन जब फ्रिक्शन काम करता है तो देयर इज अ लीकेज. द एनर्जी वॉक्स आउट ऑफ द सिस्टम. So work can do anything. Work, if it is a positive work, what it will do is it will go inside the system, see the energies there, get added, and it will see there are 3-4 types of energy in the system. It may end up increasing the temperature of the system. It may end up increasing the potential energy of the system, spring potential energy. It may also end up increasing the kinetic energy of the system. But what happens if this work is, so this is a situation where the force acted as a mechanism of push or pull to transfer energy from outside the system to inside the system. Consider the reverse situation when the energy is this and gets transferred to outside. So this had kinetic energy only, got transferred to the road, and the road became hot. So friction did the work, the push and pull mechanism, but in such a way that the energy of the system could not remain constant. Whereas here it remains constant. It keeps on changing form only from one form to another form. That is what it does here. But here, not here. It gets lost. यहाँ कोई form नहीं change होगी. Half mv square will not become mgh. Half mv square will get out of the system and go to the road and finish it off.
ठीक है.
Very, very theoretical discussion, ठीक है? मतलब you should have clarity in this chapter also and generally also कि कैसे you will solve. I saw your answers when you were explaining me about friction being, breaking the relative motion and other questions. मैंने ये लिखा है, मैं समझ गया था. You have confusion in your mind totally.
ठीक.
So when you do this question, which you just did from NCRT, this one on the previous page, ये वाला जो क्वेश्चन करा भी हमने, इसके अंदर you can write that whatever push pull mechanism you have here, the push and pull mechanism you are doing is going to add energy to the pulley, and therefore using the work energy transfer theorem. Don't use transformation, otherwise people will say फिर तो ऐसी एनर्जी को तो वो पुल्ली जो भी है ये व्हील, इसकी एनर्जी को चुरा लेना चाहिए था, स्लो डाउन होना चाहिए था. तुमने तो ऐड कर दिए सिस्टम के अंदर. हाँ करिए, ऐड करिए. तो इसका मतलब द एनर्जी वर्क यू हैव डन एज विच इज द पुल मैकेनिज्म हियर हैज just added energy to this system. So it's a transfer case. It's not a transformation case. अगर ये चल रहा होता और मैं उठा के यहाँ पे एक फुट्टा रख देता मीटर स्केल स्लो डाउन करने के लिए इसको, तो फिर जो ये इसकी रोटेशन थी वो उसका लॉस हो जाता. हाफ आई ओमेगा स्क्वायर would have left the system and got transferred to this meter scale. और ये मीटर स्केल गर्म हो जाता और यहाँ पे धुआं आ जाता. That would have been transformation of energy. हाँ जी. Clarity comes or doesn't come?
Comes.
Any doubts in your mind pertaining to work energy, reasoning, etc., etc.? Clarity, yeah? So let's meet tomorrow and continue to do this question. इसके क्वेश्चन करते रहते हैं. This is a very important topic to understand. जेईई एडवांस में भी बहुत क्वेश्चन होंगे, स्कूल में भी होंगे और मेंस में भी होंगे. और इसके बिना you won't be able to do a lot of class 12th also, by the way.
ऐसा?
हाँ, can't do.
Sure.
You have to know this. Many topics you will come across this. Everything is linked to each other. ठीक है? See you then. See you tomorrow.
ठीक है.
Take care. Bye. Please go and practice also.